Okay, so let us continue with the subtraction. As before, we talked about the addition. Whenever we have a random vector, say AB, and then you add up with the BC, then you just add up the two numbers, right? So then we might want to think, so if we have, let's say, a vector 2, 3 minus a vector, let's say, just take the easy one, say 3, 1. So then we might want to think that, will it be negative 1, 2? So then we want to check whether it's true or is that reliable or not. So let's see. What does it mean by negative 3, 1? So let's see, go back with the primary addition, subtraction, integers and all those things. If I ask you 10 minus 3, what does it mean? You know, it's 7, you know. Algebraically, it means that it could be like 10 plus negative 3, isn't it? So like when we go with probably like primary 4, we learn integers, so then we know we can you know, change the format a little bit so that it becomes, because negative is the same as plus with meet with minus, so then we get the negative, so it's the same thing. So then we get, oh, it's a 7. So the same is true in the case of this. So when we say 2, 3 minus 3, 1, it's actually the same as 2, 3, because we know addition of negative 3, negative 1. So then how does that look like? That's the thing. How does that look like when we really do the vectors? Let me change it. Let me go with another vector. So we have a 2, 3. Let's say 2, 3 here. So let's say we name it A and B. So 2, 3. And then we have a negative, and then we have a negative 3, negative 1. Let me use another color. Negative 3, negative 1, which is negative 3, negative 1 will be here. Say we name it C. So then the AC, I'll give you another color, green. So this will be the result as before, right? So now like AB plus BC equals to AC. But what is the AC? The AC itself will give us negative 1, 2, which turns out it's the same with this, which is what we expect. So then you need to see that the way we do subtraction is actually just the same with addition. But then visually speaking, it causes a problem. Now, I've not shown you in detail before, so let me show you again here. So let's say we are using the first one, 2, 3. So 2, 3. This is a 2, 3, right? And then minus 3, 1. What is 3, 1? What does it look like? 3, 1 looks like this. So if, for example, we just move this thing, oops, oh, I got a wrong thing. I moved wrong thing. Oops, my bad. So if I move the 3, 1, this vectors, I move this, even I got it here. Let's say I move the 3, 1, then I put it here, 3, 1. This is the result. So that's kind of weird, right? That's why the reason that this negative thing matters a lot. So the meaning of that is, if I erase this and then let's try to redo, you can repeat this video if you're not getting it. 2, 3, so we go with minus. Now what does it mean by the minus, the negative? So it goes from 3, 1 becomes negative 3, negative 1. That means if at first it should be like this, then now it should be the opposite. So we just change the arrow. So that in that sense, that's why it goes this way. Instead of going this way, this is a 3, 1. This is a negative 3, negative 1. And this is a 2, 3. So then you see the difference. Now then only you get this result, negative 1, 2. So then when the visual should talk, right? The visual talks that whenever we do subtraction, we have to make it the opposite. So then you can tell it's not as exactly the same as addition. So that's about subtraction. You can see further in any videos or when you go with the exercise.